Welcome, everyone, to another exciting episode in your journey of learning Microsoft Cosmos DB. I am your host for this short session, Zach Gardner, Chief Architect here at Keyhole Software. We're a consulting firm based out of Kansas City that gets to work with a lot of different clients, all the way from healthcare to energy to entertainment. You name it, we've probably done it. I have had the privilege of working with a hospital system out of New York City for about the past 8 years. And this presentation was actually born out of some of the things that we did for them in the COVID 19 pandemic. I've been able to be a developer for a very, very long time. I've gotten to try some things that worked, some things that didn't work so well. So I hope what you all get out of this is an understanding of how you can leverage technologies like Cosmos DB, how you can leverage things like SignalR, not just for the use case I present here, but also maybe for additional use cases that you have going down the road. And honestly, the first place to start with in the beginning. Now, when I was a developer just starting out, things were much more simple than they are now. And that's okay. Things should progress over time. When I was first starting out, we had very well defined C sharp classes. We spent a lot of time modeling our attributes and our relationships and our class structures, the has many and the has ones of the world. And on the API side, it was beautiful. We had these amazing models that really represented how our business users talked about the data. Things like domain driven design, think along those lines. But there was always friction. There was always a tension between our API and our database. Because when we needed to take that data and persist it off to the database, we always had to normalize it. We had to take this beautiful domain model and we had to break it apart into link tables and worry about primary keys and referential integrity. There was never a way for us to truly preserve that model through its entirety. And I mean, think about REST. REST is all about how do you transfer the state of an entity from one place to another and preserve its original form. Now, why in our right minds would we have a UI have the same representation as the API and then have to break it apart and then rehydrate the model in a very convoluted, sometimes normalized, sometimes denormalized form? So the application I was working on followed that model for a very long time, and we were successful to a degree. But as many of you know, COVID 19 changed everything. Not just the fact that we were a hospital system in New York City, but we had real software that we had to deliver to help real people. And one of the things that we quickly identified as a bottleneck, right or wrong, was our database, both in terms of performance, scalability, but also velocity. Every time that we on the development team needed to make a change on specifically the API side to the database side, we had to interact with another human being. And every time, as we all know in software, you interact with another human being, you open the potential up for miscommunications. You potentially decrease your velocity because you're having to explain and then iterate. You can't have just one person implement the full stack, or so we thought. Now, we chose during early on in the COVID 19 pandemic to really take a hard look at why it was so slow for us to deploy some features. There were a bunch of reasons, not going to get any of them, but the one reason, and the one reason why I'm here right now, is we identified that we really had documents. Everything that we were talking about in the business parlance, in the developer parlance, it was really around documents. Now, our documents, they might not have understood from a medical director or a chief medical officer level were documents, but we on the development side actually understood that all they were talking about ultimately were documents. A patient is a document. Now, a patient is a human being like you and I, unless Chat GPT or any of these other third parties are watching us. We have properties, we have relationships, we have relationships to other people, we have addresses, we have phone numbers. Some of us might even have winter addresses if you summer down in Florida. but it's ultimately rolled up and contained within the auspice of a patient. What we had done in our relational database is we had broken those apart into address tables and then patient tables, and then we needed linking tables. Well, inadvertently, we screwed some things up along the way, and some patients shared addresses, and it got to be a mess. So we understood from a technical side, one of our primary constraints was the fact that we had these data models that we were treating as documents that could be understood as atomic documents, but we weren't saving them as documents. So we looked at a number of different options out there, and Cosmos DB we selected for a variety of reasons. Its scalability was very, very high on our list. The concurrency models, granted, we're only using session based concurrency, but the fact that it offered so many different levels of concurrency allowed us to have the confidence that if we did try to choose something in the future, we wouldn't have to relearn a completely new tech stack, completely new technology. We could use what we already knew and then switch the concurrency model over. It allowed us to have logical partitioning based on a partition key, which in healthcare is extremely important, especially if you're bringing on additional organizations, storing their data, and they require it to be logically separated. Now, in the old days, what we would have done in a relational database is perhaps have a single database server with different databases partitioned inside of it. What Cosmos allowed us to do, though, is to logically separate our data based on a partition key. And as long as that partition key was based on which organization that data was for, we met all compliance and all security requirements. Velocity, too, was something that we were really looking at. It's so easy for us as developers to simply add in a new attribute or a new relationship to another class and not have to involve another team, another database team, not have to go through a provisioning process and a ticketing process. We give it a patient's container and we add in whatever we need to. So it's very easy to onboard new people. And unfortunately, we had to kind of start out with a new data model, which is both a good and a bad thing. It allowed us to separate ourselves from the legacy, all the years and years of accumulation of baggage on our existing data model, and really take a fresh look at what our patient, our document, our note, all of that data model was truly comprised of, with our ability of saying, all right, let's cut things in the sand, let's make a line, and let's choose to go this route because it's better for us as developers. More importantly, it is better for the providers that we work with because we're able to deliver them software better. They're able to get better availability out of it. And honestly, most importantly, it's the best choice for the patient. So it knocked out all three of those concerns in one shot. Now, it's not to say that when you go down the Cosmos DB route, NoSQL doesn't always mean you won't ever use SQL. Because, as any enterprise team will tell you, when you develop an application, it's not developed in a silo. Sure, the functionality might be for a specific set of users, or it might be for a particular use case. But if your application is worth its weight in salt, there's going to be reporting requirements on it. And very, very rarely is the team that develops the application responsible for doing the reporting on the application. Usually that's farmed out to a business intelligence or a data science team. What we liked about Cosmos DB, out of a lot of the other choices that we could have gone with, is that it very easily allowed us to take our JSON documents and map those over to relational tables. Now, the relational tables that they went to were highly normalized, and there wasn't a ton of data, honestly, that we had to pull out. But the ease and the flexibility of it allowed the teams that had to do reporting to use the tools that they knew and they loved and they were extremely familiar with without having to learn our new tool set. And sort of a fringe benefit, every application I've ever been on has always suffered one critical performance constraint, and one honestly constraint in terms of how much tech debt and how much legacy you have to support. It's that almost all the time, the team that is doing the reporting is doing the reporting on the operational database, which when you're beginning isn't a bad idea. And it's honestly something that I would recommend. But one of the things that invariably happens over time is because if your application is operating on the same database that a team is reporting on, guess what happens when that reporting team accidentally runs a query that is blocking? Well, all your inserts, all your updates, and sometimes even your selects can be blocked too. That's not anything bad about how Microsoft SQL Server works. That's actually a good thing because you have that transactional consistency. But what it means is that you end up having some very unhappy users. So, what you will do over time, invariably, is you will create a read only replica of your database that is asynchronously updated, and that's what the reporting team works off of. And theoretically, we could have had an asynchronously replicated Cosmos database that our application did not hit. However, what that eventually leads you to do is, well, the reporting team is calling one of these tables and they're selecting from one of these columns. So we can't get rid of it. We can't change the data type, even if within your operational piece of your application that actually makes sense. So one of the very interesting fringe benefits, it's something that I'm actually recommending any application that I work with do in the future, is have a completely separate operational database, which we chose Cosmos DB for, and then a completely separate data warehouse database. That data warehouse is the only thing that large reporting teams have access to that allows you to iterate on your schema, on your structure, on your indexing, and grow it independent of what the teams are reporting on. Now, there's many different tools that you can use to establish that data pipeline between Cosmos and SQL Server outside of the scope, thankfully, for this presentation. But there's so many options that it really behooves you to sort of look around and sort of reimagine and rethink how you've done things in the past. And oftentimes, our legacy of where we came from really impacts our mental model of how we can move forward. So, starting with the Signal R piece of it, in the beginning, life as a developer was extremely simple. When I graduated college, life was great. We had a very simple model. We had a client, which was, our web browser, and then we had a server. And a whole page was loaded. User clicks on a link. We go to the server, we get the new page back, and we're good. Well, that worked for a while until people wanted to be able to only grab certain pieces of the screen. That model that we had, that mental conception, we could kind of figure out how to do it through Ajax. And just as an aside, it always makes me laugh when I think of Ajax because the X in Ajax is XML, and this is 2023. We have rovers running around on Mars. We shouldn't be using XML unless there's a very good reason to transfer it back and forth, but I digress. Ajax came onto the scene, and it allowed us to take little pieces of the screen, whatever the user clicked on, and download that specific piece of content as a client from our server. And that back and forth worked really well. But it's a tool, and not every tool is right for every single job. There are probably 3 different scenarios that I have had in my career where Ajax honestly wasn't the right tool. One of those is reporting. Now, most applications that I work in offer some sort of ability to do ad hoc reporting where a user can go in and select a certain number of fields to filter by, columns to sort by, paging, yada, yada, yada. They'll go and they'll click, they'll sit, and then they wait because ad hoc reports take some time. They're not things that oftentimes we can cache ahead for them. So one way to initiate that kind of request is using Ajax, which, it's a great tool, but it's meant for very short, simple bursts of traffic between a client and a server. What happens when that response needs to be very large? I'm talking, not just megabytes, but tens of megabytes, 20s of megabytes, or potentially even, heretically 30s of megabytes. Not that great for it. And what happens when that transaction runs a really, really long time? Because ad hoc reports often need to. Well, even though we were using SignalR, and even though we were using Cosmos DB, some of our reports would just take a long time because they were running on fields that it hadn't proactively indexed. And there was nothing we could really do other than indexing every possible field, which has its own negative implications. There's not much we could do about it. So the reports took a long time. That's just sort of a reality of our life in 2023. We could kind of explain that away. The one thing that we couldn't explain away are phone calls. Now, you don't know. Clinical call center agents, especially in a hospital system, they are some of the most overworked and hardest working people that get little to no thanks. So the next time you call into a call center, just a PSA, thank them for what they do because they have a very, very hard job. And what we found out was happening was patients would call in and the clinical call center agent would receive that on a desktop application. They would get to see the phone number of the person that called in. They would get to see probably the campaign that they called into. That's sort of lingo for which program or what initiative they were calling in for. And over the phone, the patient had to tell them what their name was. Now, for someone like me, Zach Gardner, people often misspell my first name. And that's okay. Phonetically, I totally understand why. But that can have patient identity issues down the road. I'm not talking cutting off the right leg when they should have cut off the left, but it means that matching doesn't work. Maybe relationships, next of kin don't work. There's a lot of implications of getting that piece of information wrong, or birth date, or gender. It's hard, honestly, to take a lot of that information over the phone, especially when the patient is in a life critical situation. So we had a couple options. We had many different tools at our disposal. We had Cosmos DB, which it had a lot of good things that we could do, like being able to search for phone numbers really quickly. We could index that field and we would be able to see, oh, a patient is calling in from this phone number. Here are all the other patients that have called in with that phone number as their primary. But how do you know when to search? We could have just presented a screen to the call center user, letting them type in a phone number whenever someone called in, but those are critical seconds that they take from being able to actually provide care for the patient. And when you're in a life-threatening situation, every second counts. So instead of doing that, what if there was a way that we could, when a phone call comes in, route that information from our desktop application, the soft phone that was actually receiving the phone call, route that information to our web browser? Easier said than done. And we tried a lot of things. There was success and failures, more failures, honestly, than successes, but where we coalesced around, and this is one of the reasons why I'm a PSA, this is, my good deed for the day, is SignalR helped us. SignalR allowed us to route messages from our C# code where we would receive information about the phone call and in real time send it to the browser. And that information could be enhanced because we could pull from an API what the name was associated with that phone number, maybe any past visits, if the patient had visited the ED or visited their primary provider recently. All of that could be sent within seconds to the browser without having a long-running AJAX polling request that could potentially miss when one of these messages came in. One of the other cool things that we could do with SignalR is that we could, based on the campaign that the patient dialed into, understand which workflow that the clinical call center user should follow and be able to guide them and maybe potentially pre-select things on the screen. Now, if you would have told me 5 or 6 or 7 years ago that this was possible, I would have called you crazy. But no, All of these pieces of technology, Azure SignalR, Cosmos DB, they can all work in tandem. And one of the amazing benefits for us was also financial. It's a lot cheaper, honestly, for us to run these services in the Microsoft Azure cloud than it would ever be for us to run these kind of things on-prem. Now, there are some hidden costs that Microsoft spends to be able to keep these things running because it's not trivial. It's not easy to keep all this stuff with such high availability levels. And if you choose to do it on-prem, I mean, that is certainly an option that you could go down if you really wanted to, but there are hidden costs because it's not going to be the operations team that responds more than likely at 2 in the morning when one of these things goes down. It's the development team. It's the development team that is going to keep these things patched. And with the proliferation of DevOps, that's even become more of an onus onto the development team to really understand all the configuration files that go into these two particular services. And so you end up having your developers doing things that are not pertinent to the business functions that you're trying to deliver. Cosmos DB and SignalR, one of the other reasons why I'm talking about it today, and hopefully enlightening you all on how I approach these different problems, is the fact that it allowed me to spend more time focusing on business specific use cases and code and data modeling and mapping than it did purely engineering problems. Things like how do you keep one of these services with high availability? We were able to defer that cost to Microsoft and in the end, save money in the long run while still being able to deliver on time, often ahead of time, as well as under budget. And these two services, Cosmos DB and Azure SignalR, are extremely powerful. Any application that I go into in the future, those are going to be some of my first choices to bring in. Now, that's not to say that NoSQL is right for everything. There are some situations where SQL might be right, and that's okay. It's a tool that we can use. And what's more important than any particular technology that we choose, any particular architecture that we choose, is that we truly understand what our business is trying to accomplish. And we, as architects and developers, we have a fiduciary obligation to those that we serve to make sure that we are providing them with the best guidance, the best advice, and using, at the very end, remember in the Agile hierarchy, people, process, tools, the right tools for the right job. And in the end, Azure SignalR, as well as Azure Cosmos DB, checked all of those boxes for us. So if you want to scan the QR code, let me know how I did. Again, my name is Zach Gardner, Chief Architect here at Keyhole Software, and this has been my presentation for the Azure Cosmos DB conference. Thank you very much.